Problem 2a. A car traveling at 35 meters per second suddenly runs out of gas while driving up a 7-degree incline. How long will it take for the car to stop after it runs out of gas, assuming no friction and no brakes are applied? How far will it travel before it stops? And so let's first draw a diagram for this. So I already drew a diagram, and pretty much as you can see, there's a car driving up a 7-degree incline uphill and traveling at 35 meters per second. We're trying to solve how long will it take before, when the velocity is 0 meters per second, how long will it take for that to happen, and how far will it travel when that happens? So let's first solve for how long it will take. So let's first write out the given information that we have for this problem. So the car is traveling at 35 meters per second. So we know the initial velocity is 35 meters per second. And then we know the final velocity will be 0 meters per second, right? Because that's when the car stops running. So we know that. And then we also know what acceleration is, right? Because it's going uphill. So first off, it will be negative, and then it will be 9.8 sine whatever the degree of the angle is, and it's 7 degrees, so it'll be 7 degrees. And it'll be meters per second squared. And then again, we're trying to solve for time first. So in order to solve for time, we can use the equation VF equals VI plus A times T. And then we just plug in the values. And then we're solving for T, so we just plug in the values. So it'll be 0 meters per second equals 35 meters per second plus negative 9.8 sine 7 meters per second squared times T. Okay, and then let's try getting T by itself on the same side, and then we can do that by simply just subtracting 35 meters per second and also dividing 9.8 sine 7 degrees on both sides. So it'll be negative 35 meters per second over negative 9.8 sine 7 degrees equals T. And then this will just simplify out to 29.31. This is meters per second squared. And then the units will just simplify out to seconds on the top, because meters per second over meters per second squared. So it'll be the time will equal 29.31. And then, like we said, the next thing we want to solve for, how far will the car travel before it stops, right? So we can simply just use the formula D equals VF plus VI over 2 times T. And now we actually know what T is, right? So we can use this equation. We can given the information. So we just plug in the values again. 0 meters per second plus 35 meters per second over 2 times 29.31 s. All right, and then that will just equal 512.925 meters, because meters per second times second. This equals meters. And that's so then the distance traveled before the car stops will be 512.925 meters, and the time it will take before the car stops will be 29.31 seconds.